Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you all to the lecture 9 on crystallography course offered by us. Today we will discuss about the isometric crystal forms, and in the last class we introduced crystal forms and we discussed two types of isometric crystal forms, namely cubic form and dodecahedron form. And today we will continue further and we will see the remaining crystal forms under isometric crystal system. And after that we will discuss about the crystal forms in non-isometric crystal systems. So, essentially in crystal systems belonging to triclinic, monoclinic, orthorhombic, tetragonal, trigonal and hexagonal crystal system. Okay, so let us have a look at the next isometric crystal form, and this form symbol here is HK0. H is not equal to K, and let us discuss about this particular crystal form in terms of a representative crystal phase, which is 210 here. So, when we talk about HK0, we again remind you that when 0 is there in the position of C, it represents it's a vertical crystal phase. So, let us consider that we take H is equal to 2 and K is equal to 1. So, it becomes the crystal phase is a 210, and immediately you know the position of this particular 210 is in between this point here, which is 100 and this is 110. So, 210 will lie in the zone between 100 and say 110. So, if we have this 210 is the position here, then what will happen here? It will be acted upon by this triad here. So, I am discussing this with respect to the crystal system with respect to the point group of symmetry, that is 2, 3. And what we have in 2, 3, let us recapitulate once again. That there are 3 diodes. This one is a vertical diode, and this one is a horizontal diode of this orientation, and this is another horizontal diode of this orientation here. And the 4 green triangles, they represent 4 body diagonals and they are triads here. So, if this is the position of 210 crystal phase, so then this triad will act upon this and it will rotate 120 degree and along this direction here, and it will bring this to this point here, and this will still be an open circle that is shown by the red outline here. Another 120 degree rotation will bring this red circle to this red circle here. So, let us try to understand what will be the nomenclature of these 2 red circles. That means, 2 phases that are generated with this starting phase here. Now, this phase is the one which lies, say for example, this point, this is 001 and this is say 010. So, in between we have that is 0111, and this open circle here lies between 011 and 010. So, it will be the one which is 021. When we have in the third position here, that is the position of C, this is positive, that means it is intersecting the positive direction of the A3 axis here. Now, let us again consider this red circle here, and this is 0 to 1, and this will be acted upon by this triangle here, and this threefold axis symmetry here, and 120 degree rotation will bring this 0 to 1 to this position here, and another 120 degree this will be brought to this open circle position here. Now, what will be the Miller index symbol of these two faces, one at here and other at here. Now, let us see, we know that this is your 0 1 0 and this point here is bar 1 0 0 and this will be the 1 which will be bar 1 1 0. So, it intersects the positive direction of A2 axis, but negative direction A1 axis. So, this is bar 1 1 0. So, immediately this will lie in the zone between bar 1 0 0 and bar 1 1 0. So, it will be the symbol will be here bar 2 1 0 here. And what will be the symbol of this crystal face here, which lies in the crystal zone between 0 0 1 and here, that is this will be 1 0, this will be this is be bar 1 0 0. So, this will be this position here in the midpoint, this will be bar 1 0 1. So, it will be lying between bar 1 0 1 and 0 0 1. So, this will be bar 1 0 2 here. Now, this will again be acted upon by this triad here, and this will be after 120 degree rotation, this open symbol will be rotated to this position here. So, what will be this position here? So, this will be this face will be a vertical face and lies in a zone between bar 1 0 and bar 1 0 0. So, it will be the nomenclature will be bar 1 bar 2 bar 1 0 here, and this one will be rotated 120 degree. So, this will bring this particular open circle here, and this will be this will be lying between this point here, that will be your 0 bar 1 1 and this is bar 1 0 0. It lies in the zone between this. So, it will be by applying the additive rule here, it will be 0 bar 2 1 here, this open circle here, and after this will now be acted upon by this triad here. So, this open circle after 120 degree rotation will come here, and this will be the position here will be 2 bar 1 0 here. So, in nutshell, this operation of these 4 triads now with this starting motif or this face 2 1 0 has now produced 1 2 3 additional vertical faces here, and it has produced 4 inclined faces. All has been all these inclined faces intersect the positive direction of the A3 axis here. Now, you also have this horizontal two-fold axis, one passing through this and another horizontal two-fold axis passing through this. What will happen here? This particular horizontal two-fold axis will act upon this face here, that is 1 0 2, and after 180 degree rotation, this will be repeated here a face which will intersect the negative direction of A3 axis, and the symbol of this will be bar 1 0 bar 2, and this has been shown by this cross here. The cross, the symbol refers to a crystal face which intersects the negative direction of the A3 axis. Once you generate a cross here, immediately this cross will be rotated 180 degree with respect to this vertical two-fold axis symmetry, and will generate a cross here. This cross represents what will it represent? It will represent the face which intersects the negative direction of A3 axis. So, if 102 is the face which intersects the positive direction of A3 axis, the negative direction of the A3 axis, that face will have a symbol 10 bar 2. So, the next one is this one here. If we talk about this horizontal two-fold axis, this open circle now will be acted upon this horizontal two-fold axis, and this is the one where the face intersects the positive direction of A3 axis. So, after 180 degree rotation of this horizontal axis, this face will be repeated here as a face which intersects the negative direction of the A3 axis. So, and the symbol will be 0 bar 2 bar 1 here. Same way, this cross, which is the one which intersects the negative direction of A3 axis, after 180 degree rotation with respect to this vertical diode here, this will be repeated in this particular place here, this cross here, which will represent 0 2 bar 1. Now, what does it mean here? So, how many total crystal faces are generated with this starting symbol here 210? They are 12 in number. The 4 are vertical and there are 8 inclined, and 4 inclined faces, they intersect the positive direction of the A3 axis, which is shown by this 4 circle here, and there are 4 inclined faces which intersect the negative direction of the A3 axis. These are shown by the 4 crosses here. So, this 12 faced form is given a name called pyritohedron, and this is present in the crystal pyrite, and this is the crystal model of a pyritohedron. You see that each face is a pentagonal shaped face here, and this is the one in a cube. These are the positions of A1 axis, A2 axis and A3 axis here, and you see that all these faces here 2 1 0 0 2 1 and 0 2 bar 1, they intersect at this point. This is the position of a triad here. Okay. Now, we have developed this, we have seen this 12 faced form here using this particular point group of symmetry here 2 3. So, if you change the point group of symmetry to 2 over m bar 3, what happens? So, this 3 2-fold axis remains. Essentially, you have perpendicular mirror planes, which is now shown by these 3 bold lines here, and this is the horizontal mirror plane perpendicular to this vertical 2-fold axis symmetry, and these are the positions of triads here. Essentially, you have a bar 3, that is the center of symmetry here, which is shown by this yellow circle here inside this triangle here. Importantly, if you start with this 2 1 0 again here, you will have the same pattern of the faces that you have seen with 2 3. So, therefore, pyritohedron, which is an HK0 general form symbol, is present in isometric crystals belonging to 2 3 and 2 over m bar 3 points group of symmetry here. And these are the 12 crystal faces that has been written here. So, I am not repeating here, which I have also shown them in this stereographic projections here in these 2 diagrams of 2 3 and 2 over m bar 3. Now, let us now go to the next stage here, where the form symbol will remain the same. What will happen here, what will you do here is that we will just change the point group of symmetry to the remaining 3 points group of symmetry under the isometric crystal system here. And I am showing this with this among the 3 remaining in this diagram. I am showing this with 2 here with 4 3 2, 4 over m bar 3 2 over m, and you also have bar 4 3 m, which I am not showing here, but it will also yield the same pattern here. Now, what you have here? So, this is the, if we start with 4 3 2, so you have this 3 4-fold axis symmetry. This is the vertical 4-fold axis. So, this is your also the A3 axis, and this is the horizontal 4-fold axis, which coincides with the A2 axis, and this is another horizontal 4-fold axis, which coincides with the A1 axis here. And you have in 4 3 2, there are 6 diodes. This is this one, and this one is your horizontal diode. So, there are 2 horizontal 2-fold axis symmetry, and these 4 are the positions of 4 inclined diodes or edge diagonals here, and this green one, they represent the 4 triads here. Now, let us see this particular one here. Although this diagram seems slightly more complicated, let me explain and you will be able to understand how all these motifs or the positions of different crystal faces that can be formed here. Now, this is your 210 and you have to if this will be acted upon this triad here, and as we have done it here, this open circle after this rotation of 120 degree, this open circle will come here, this open circle will come here. And what will happen here is that, as we have done with respect to 2 3 and 2 over m bar 3, this open circle will again be acted upon by this triad, and what will happen here? You have this open circle here and you also have this open circle here. So, in a way this open circle and will be repeated by this the symmetry of this points group or all the symmetry axes that we see here. So, this after this will acted upon by this. So, you have this face will be generated here, and once you have this face generated here, you have this particular face generated here and another face generated here. So, in nutshell now that the same 12 faces that we have generated with 2 3 and say 2 over m bar 3 will also be present in 4 3 2. Now, what you have here is that you have this horizontal two-fold axis which was absent in 2 3 and 2 over m bar 3. This two-fold axis will now act upon this 210 here, and you will generate another face here at this point here. And what will be its name here? It lies between 110 and 010. So, if you apply the additive rule here, and then this will be the face will be 110 and 010. So, it will be this will be 120. So, this will be the name of the 120 face here. So, as soon as you have this 120 here, immediately what will happen here? This particular face will be acted upon by this triad here, and you will generate another open symbol here, and then this open symbol will be acted upon by this triad here, and will generate this open symbol here. So, what happens here? Because of this symmetry in this particular point group, that is this dyad will enable the generation from this 210 another vertical face 120, another inclined face which will nomenclature will be between 001 and 011. So, this will be 012 here, and this will be this open symbol here. This will be the one which will be lying between 101 and 100. So, this will be 201. So, in the same way, what will happen here is that you have generated 3 open symbols here with the starting one. Same way here you have generate this particular open symbol here, you will generate this open symbol here, and this already we know this is the we have generated here. So, and then this particular two-fold axis of symmetry will now also act upon this particular open symbol here, and 180 degree rotation will generate a cross here. So, there will be a face which will intersect at the negative direction of the A3 axis here. Once you have this cross, so you can understand this cross will be acted upon this vertical fourfold. So, you can have a cross here, you can have a cross here, you can have a cross here. So, in nutshell now, what you have here in this particular case, a total of 1, 2, 3, 4, 5, 6, 7, 8. So, you have an 8 vertical faces here, and what you also have a 16 inclined faces here. Among these 16 inclined face, so how do you know that 16 inclined face? So, in this along the A1 axis we have this 2 plus 2 4. So, 4 into 4 16 inclined faces. Among this, the open circle, they are 18 number 1, 2, 3, 4, 5, 6, 7, 8. So, this 8 open circles here, that means there are 8 faces which intersect the positive direction of the A3 axis, and there are also 8 crosses here. Those 8 faces, they will intersect the negative direction of the A3 axis. So, what we have here is the same form symbol in this point group 4, 3, 2 has generated 24 faces here. In the earlier case, there are 12 faces here, but here you have 24 faces. Immediately you now know the form or the aggregates of crystal faces which are symmetrically related to each other, their number. They are a function of their inclination with respect to the 3 axis, which is the form symbol, as well as the point group of symmetry that is present there in that particular crystal system here. So, with the starting form symbol 2 1 0 in the 2 3 and 2 over m bar 3 point groups, you have 12 pentagonal shaped faces were generated. We call it as paritohedron. But here in this particular case, these 24 faces give rise to a crystal form which has been given a name called tetrahexahedron. So, hexahedron is essentially another name of cube. So, when you tell tetra, hexahedron are 6 faces here, and now each face now breaks up into 4 triangles here. So, 4 into 6, there are 24 faces, and this is an crystal model of tetrahexahedron. You find out that this is your A1 axis, this is your A2 axis, and this is your A3 axis here. Immediately you can find this is your 100 face in cube or hexahedron, then this has now been divided into 1, 2, 3 and 4 triangular shaped faces here. So, each hexahedron faces, if it is now consists of 4 faces here. So, 6 such original cubic faces will now give rise to 6 into 4, 24 faces here, and this kind of tetrahexahedron will be present not only in 4 3 2, 4 over m bar 3 2 over m, and you can also study on your own in the point group of symmetry bar 4 3 m. So, you see that I repeat once again, if you start with a general form symbol of HK0, this can give rise to 2 broad varieties of forms here in isometric system. One type of form will be called paritohedron, and other variety of form will be called tetrahexahedron, and this depends on the type of point group of symmetry here. Okay. Let us go to the next crystal form in the isometric crystal system here. And here we now consider a general face here as 1 1 1, and 1 1 1 refers to a crystal face which intersects all the 3 crystallographic axes A1, A2 and A3, and they intersect at the same unit lengths here. Now, question is, what will be the position of 1 1 1? Now, 1 1 1 is a crystal face which is at an angle which is perpendicular to a direction which has the symbol of 1 1 1. That is 1 1 1 under second bracket is a direction here, is essentially a crystallographic axis, and that crystallographic axis is a triad. Now, if you have a face which is essentially is perpendicular to the triad, immediately you know the triad will have no role on this 1 1 1 phase. So, even if you have the triad will not generate additional phases from 1 1 1. Now, where your 1 1 1 phase will plot? Let us consider this particular point group of symmetry, that is 4 3 2. Now, you now know this particular point here, which has a mirror index symbol at this point. If there is a phase, this is 1 1 0 and this is the point which is 0 0 1. So, 1 1 1 will lie in a zone between 0 0 1 and 1 1 0, that will be somewhere here, and this is essentially the position of the threefold axis of symmetry here. So, this is your position of 1 1 1, which is the position where it intersects the positive direction of the A3 axis. If this is the situation here, immediately you can understand that if you have a vertical fourfold axis, this phase will now be rotated 90 degree and this will be repeated here, another 90 degree it will be repeated here, another 90 degree it will be repeated here. So, this will be shown by this open red circle 1 2 3. Now, what will be the nomenclature of this open red circle here? Immediately you know this lies in the quadrant in the positive direction of A2 axis and the negative direction of A1 axis. So, it will have a nomenclature bar 1 1 1. What will be the nomenclature of this phase here? It lies in the negative direction of A1 axis, negative direction of A2 axis. So, it will have a nomenclature of bar 1 1, and this is the one which lies in the negative direction of A2 axis and the positive direction of A1 axis. So, its nomenclature will be 1 bar 1 1. Now, what you have here is that you also have a diagonal dyad passing through this here. So, immediately you know this open circle will be rotated with respect to this horizontal dyad, and this phase which is intersecting the positive direction of A3 axis after rotation will produce another phase which will intersect the negative direction of A3 axis and its position will be diametrically opposite here. And since it is intersecting the negative direction of the A3 axis, its symbol will be a cross here, and the position is here is that it is also in the negative direction of A2 axis, but the positive direction of A1 axis. So, we will just give a nomenclature 1 bar 1 bar 1. So, once you generate a cross here, the vertical fourfold axis will rotate this cross and will produce a cross here, it will produce a cross here, it will produce a cross here. So, you have 3 faces which will intersect the negative direction of A3 axis are generated here. So, you now have from a starting 1 1 1, you have a total of 8 crystal faces here, and this 8 crystal face among this can be subdivided into 4 which intersect the positive direction of A3 axis, and there will be 4 which will intersect the negative direction of A3 axis. These 8 faces, these are equilateral triangles, they give rise to a crystal form which has been called octahedron, and this is the model of an octahedron here. This is your A1 axis, this is your A2 axis, and this is your A3 axis here, and I have shown you these 2 faces. I have given the name here. This is this frontal face here which intersects the positive direction of A1, positive direction of A2 and the positive direction of A3. This is your 1 1 1, and this is the one you can appreciate here. This face intersects the positive direction of A1, the negative direction of A2 and the positive direction of A3. So, you give a name here 1 bar 1 1, and you can also appreciate these 2 faces here. This face here, it intersects the positive direction of A1, positive direction of A2 and the negative direction of A3. So, it will be having a symbol of 1 1 bar 1. whereas this triangle is the one which intersects the negative direction of A3, the positive direction of A1 and the negative direction of A2 will be given a symbol of 1 bar 1 bar 1. And I have given the names of these 8 crystal faces here, which are octahedron, which are related to each other in octahedron here. So, I have again repeat here that I have already told the most critical part here, this 1 face is perpendicular to the triad, that is why they will not be repeated here. So, symmetry axis of A axis, so that is here the 4-fold axisymmetry, they relate 1 1 2. So, 7 additional faces, and we see these in crystals magnetite, chromite and spinel, essentially the spinel group of minerals we see here. And this is seen in 432, 4 over m bar 3 2 over m and also 2 over m bar 3. But what happens to the same crystal face with the symbol 1 1 1 if the point group of symmetry changes to bar 4 3 m and 2 3. So, let us see what happens here. So, this is your bar 4 axis here, and immediately you know that if your starting motive position is 1 1 1. So, you know that bar 4 axis is essentially a type of axis which behaves as a 2-fold axisymmetry. Immediately you know that this open symbol, that is 1 1 1, it has intersected the positive direction of A3 axis. After 180 degree rotation will be regenerated here as another phase, which also intersects the positive direction of A3 axis, but this phase will now intersect the negative direction of A1 axis and the negative direction of A2 axis here, and it will be given a symbol of bar 1 1 here. You also think of this horizontal bar 4 axis, which is essentially a dyad, and this open symbol after a rotation with respect to this horizontal dyad will generate another phase here, which will now intersect the negative direction of A3 axis, that is why shown by this cross here. Once you have a cross here, this vertical bar 4 axis will act upon this and will generate another cross here. And what will be the symbol of this cross? This is the cross which intersects the negative direction of A3 axis, but lies within the quadrant of negative direction of A2 and the positive direction of A1. So, it will have a symbol of 1 bar 1 bar 1, and this will have bar 1 1 bar 1. And if you go to 2 3, it will have the same combination here. So, you see that as you change the point group of symmetry, the same face now gives rise to only a total of 4 faces here. Here there are 8 faces, these are 4 triangular shaped faces here, and these 4 faces, if you see here, so this we call it as tetrahedron here, and this is an example of this tetrahedron here, and this is the position of your bar 4 axis, that is your A1. This is another horizontal bar 4 axis, this is A2, and this is your vertical bar 4 axis, this is your A3. And this 4 faced form, which we call it as tetrahedron, and they are seen in point group of symmetry as 2 3 and bar 4 3 m. And as we have discussed in the case of octahedron, because this face is perpendicular to the A3 axis, so A3 axis will not act upon this, and it will be essentially acted upon by the symmetry of the A1, A2 and A3 axis. Now, what is important here is that if you have 1 1 1 as the general form symbol here in tetrahedron, we call this as the positive tetrahedron. But you can also think of a situation that instead of taking 1 1 1, you can also think of another crystal face which is 1 1 bar 1. That means, that face will intersect the negative direction of your A3 axis. So, that means, you will start with a cross here, and this bar 4 axis will will act upon this cross and it will produce a cross here, and in that situation the what will be the phase symbol of that cross? It will be bar 1 bar 1 bar 1. Now, this particular one here, this horizontal power 4 axis will act upon this bar 1 bar 1 bar 1 will now generate a open symbol here, and what will be symbol? 1 bar 1 1, because in that situation the open symbol represents the phase intersecting the positive direction of the A3 axis. Now, if you have a 1 bar 1 1, then you will also generate an open symbol here, that will be your bar 1 1 1. So, you still have 4 crystal faces, only the faces, their symbols are different, and they are essentially pairs of faces which intersect the negative direction of A3 axis and the positive direction of A3 axis. This 4 faced form, this will also be a tetrahedron, but we will call it as negative tetrahedron, and both forms they develop in the same crystal. In the same crystal you can see both forms developed. Sometimes we see they are developed unequally. One type of form is developed in greater proportion compared to the other, that is very well developed, the other is less developed, and the other possibility is that this is equally, both the forms developed equally and they mimics a true octahedron here, and the other possibility is that only either of the two is present in a crystal, either you have a positive tetrahedron or a negative tetrahedron here. Okay. So, we now we have concluded now octahedron and tetrahedron crystal forms in an isometric crystal system here. So, let us now study another type of form which intersects all the 3 crystallographic axes, and here only important thing here, it is not intersecting all the crystallographic axes at equal lengths here. Let us consider the symbol of this form is HHL, that means along the A1 and A2 this particular the intercepts are the same. Now, depending on the value of H and L, you can have 2 situations here, one in which H is greater than L and the other situation is H is less than L. So, this is very nicely shown with respect to this diagram here. Now, this is the position, this is your positive direction of A1, this is the positive direction of A2, and this is your A3 position here, and you also know that this is 1 0 0 crystal phase here, this is 0 1 0 crystal phase. So, automatically you know this is the 1 1 0 crystal phase here, and you also know at the midpoint of 0 0 1 and 1 1 0 you can have a crystal phase, this is 1 1 1, that is also the position of this triad here. Now, you can go towards the A3 axis or you can go towards the 1 1 0 phase pole or pole here or the phase here. Now, if you are here, then you will be in a zone between 0 0 1 and 1 1 1. So, you can have a phase which is 1 1 2. So, you see this 1 is less than 2. So, this is a situation, the position is H is less than L, and here you have a situation here that is 1 1 1 and 1 1 0. So, if you apply additive rule here, it will be 2 2 1. So, this particular H is greater than L here. So, what you can do here, you can start with in one situation, that is H less than L, that means you start with 1 1 2, and since this does not coincide with the position of the triad axis, the triad will act upon it and will produce 2 motifs here, one here and the other here through 120 degree rotation, and we will call it as 2 1 1 and 1 2 1. Whereas, if you have this particular position starting motif here or starting phase here 2 2 1. So, this triad will act upon it, and after 120 degree rotation it will produce 1 2 2, and this is 2 1 2 phase here. So, these two fundamental types of motifs with a starting motif 112 or 221 can now be acted upon by or can be acted upon by 5 point group of symmetry in the isometric system, and let us see what happens here. Now, you see here this is the one h less than L. So, we start with 1 1 2 here, and what will happen here is that in point groups 2 3 and bar 4 3 m. So, this is the one here, this is 2 3 and bar 4 3 m. So, what you have is here is that this is the one is 1 1 2, and what will happen here, it produces this symbols here. This is positive directions of A3 axis, and since this is a vertical two-fold axis. So, this will be after rotation, this will be repeated here, this will be repeated here, and this will be repeated here. So, this is again the set of symbols here is the open circle here, that means they are intersecting the positive direction of A3 axis here. Since you have this horizontal two-fold axis, so what will happen, this open circle after 180 degree rotation here will be repeated here as a cross, that means this face will imply the intersections in the negative direction of A3 axis. So, once you have a cross here, this triad will generate another two crosses here, and this two-fold axis of symmetry will generate these three crosses here. So, what you have here is that you have a total of 3 into 4, 12 faces will be generated here, and these 12 faces we call it as thrice tetrahedron here. So, what does it mean? You read it in two parts here, thrice, that means 3, and tetrahedron, there are 4 faces here. That means, each face or each triangular shaped face in a tetrahedron now consists of 3 faces here, 3 triangles here. So, you see this 1 1 1 form is now essentially consists of the faces here. This we call it as thrice tetrahedron here. But if the same 1 1 2 form is acted upon by the other 3 remaining points group of symmetry, that is 2 over m bar 3, 4 3 2 and 4 over m bar 3 2 over m here. So, what will happen here is that once you have 2 over m bar 3, that means you have a horizontal mirror plane here, and with respect to each two-fold axis there is a perpendicular mirror plane, one of this orientation and another of this orientation here. So, with our knowledge before that if your starting symbol is here, that is this particular here open circle here. So, through reflection of the horizontal plane you will generate 3 additional motifs or 3 additional faces, which will now produce faces which will intersect the negative direction of A3 axis. So, at each place here you have 1 2 3, there are 2 faces here. So, this is true everywhere here. So, here you have 12 faces here. So, 12 into 2, that means you have 24 faces here, and these 24 faces are present in 2 over m bar 3, 4 3 2 and 4 over m bar 3 2 over m. We call it as trapezohedron. So, these are essentially this trapezohedron face here, and this is essentially what you have. These are the triad here, and this is the position of, say, in this particular case two-fold axis symmetry, in this case it will be 4-fold axis symmetry here. Now, if you have a case here where h is greater than L, so your starting face you can consider 2 to 1, and if you consider 2 3 and bar 4 3 m as we saw here. So, in this case what will you have? The same thing. So, same set of open circles in these 2 quadrants and crosses here in these 2 quadrants. Again you have a set of 12 faces here. This we call it as deltoid dodecahedron here. So, this is deltoid dodecahedron. So, 12 faces. So, in case of dodecahedron the faces were rhombic, but this face is such that we call it as deltoid dodecahedron. And if you have a situation that you have 2 over m bar 3 and 432 and 4 over m bar 3 2 over m. So, you will have, as we have seen before, there will be a set of 24 faces and we call it as thrice octahedron here. So, you have an octahedron face, that is 111. There are 8 such faces in an octahedron. Each octahedron face now consists of 3 triangular faces, as has been shown here. This is your 111 octahedral face. Now, it now consists of these 3 triangular faces here. So, 3 into 8, there are 24 faces here. We call it as thrice octahedron. So, we have studied thrice tetrahedron and thrice octahedron, and you also have a trapezohedron and you have deltoid dodecahedron. Now, you have here is the remaining part of the isometric crystal forms. This is the general form symbol here, HKL. This we have already studied when we have generated the 32 point groups of symmetry. You go back and see the lectures where I have taught with a starting motif HKL, and we have studied the point group of symmetry 2 3, 4 3 2, bar 4 3 m and 4 over m bar 3 2 over m and 2 over m bar 3. There you see that when you have 2 3, you have a 12 face form. So, this is shown here and this is called tetratoid. When you have 2 over m bar 3, we have 24 faces here. This is the model of that. We call it as diploid. When you have a bar 4 3 m, something like that, we call it as hex tetrahedron. So, instead of 3 faces in tetrahedron, thrice tetrahedron, your hex means there are 6 faces here. So, 6 into 4, you have 24 faces here that you see here. So, this face here now consists of 6 triangular shaped faces 1, 2, 3, 4, 5, 6. So, we call it as hex tetrahedron here. And when you have here 4, 3, 2, there you have this one here, this we call it a gyroid and there are 24 faces here. And you now know which is the normal class of the isometric crystal system, which we have 4 over m bar 3 2 over m. We have with the starting motif HKL, we have a total of 48 crystal faces here, and this we call it as hex octahedron. So, we have studied hex tetrahedron, hex octahedron, that means an octahedron face that is 111 is now consists of 6 such faces here, and this is essentially this octahedron here. Now, you see one octahedral face now consists of 6 faces. So, 6 in octahedron, a total of 8 faces there. So, you have a total of 48 crystal faces here. So, in nutshell, now you have the form symbols in isometric crystal systems. You can recapitulate. You have 100, you have 110. So, this 100, this is your cube, 110 is your dodecahedron. Then you have here that is HK0. So, in case you have pyritohedron, and then you have the other one we have studied, this particular one where you have tetrahexahedron, and then we have studied the 111, we have octahedron and tetrahedron, and then you have studied HHL form here. So, you have a 4 types that we have studied here: thrice tetrahedron, trapezohedron, deltoid dodecahedron and thrice octahedron, and the general form symbol HKL. So, we have 5 varieties that we have studied here. Now, let us go to the crystal form here in the isometric system. So, here in some cases the isometric crystal may have a combination of crystal faces. Here I am showing you a combined crystal form here, where 3 fundamental types of isometric crystal forms are combined here. So, this is a crystal, there are 3 types of crystal faces here, one of this type, one of this type and the other of this type. So, this is your 100 cubic form here. So, there are 6 such faces here, and this is the one which you have here. This is 110 form here, form symbol. These are 12 such faces are there. This is the dodecahedron crystal form here, and this is the one which is an octahedron form, and which is 111 symbol here. So, there are 8 such faces here. So, in crystals you can have a combinations of crystal forms here. Now, let us now start with the non-isometric crystal forms here. There are 2 types of non-isometric crystal form. One type we call it as open form here, that does not enclose a volume. So, obviously, we require 2 such open forms to enclose a volume here, and you can also have a closed form which is encloses a volume here. So, minerals could have more than one form, closed or open. There are this non-isometric forms can be subdivided into 10 types. So, we will now study each type under these 10 categories here. The first one is called Pedian. So, this is a single phase and there is no symmetrically identical phase. And this is essentially in triclinic crystal system, where the crystal class or point group of symmetry is 1. Now, you have the second one is called pinacoid. This is also an open form. So, there are 2 parallel faces, they can be related to each other by a mirror plane or by inversion. When you have an inversion, then this is bar 1 that we see in triclinic crystal system, and when you have mirror planes, that means that will be in the monoclinic crystal system. And you have dihedron, they are open forms here, they can be subdivided into 2 types. Essentially, dihedron represents 2 non-parallel faces, and they are related by a mirror. When they are related by a mirror, we call it as a dome. When they are related by a twofold axis of rotation or dyad, we call it as sphenoid. So, let us see how these forms look like. This is your single phase here, this is your pedian. Now, if you have this phase here and if you have a center of symmetry here, you generate another phase here at diametrically opposite direction, and these 2 parallel faces we call it as pinacoid. And these 2 crystal faces they intersect at this point. So, non-parallel faces, if they are related by a mirror, we call it as dome, and if these are related by a dyad, we call it as sphenoid. So, you now know that when you have a mirror, that means in dome the 2 faces they change their handedness, whereas twofold axis is a proper axis. That is why in sphenoid the faces retains handedness. Now, let us study the third type of fourth type of form, we call it as prism form here, and this is an open form here. So, what are prism forms? So, they are a collection of 3, 4, 6, 8 or 12 faces. They are mutually parallel to each other and they intersect, the faces intersect along a line which is parallel to the vertical crystallographic axis. What is a pyramid? This is a collection of 3, 4, 6, 8 or 12 faces. They intersect at a point. And what will be a dipyramid? This will be a closed form here. And this is a collection of 6, 8, 12, 16 or 24 faces. Essentially, there are 2 pyramids at each end of the crystal. So, you see when we talk about pyramid, we just have a double of these values here. So, 3 it becomes 6, 4 becomes 8, 6 becomes 12, 8 16, 12 24, and we will see why this is so. In dipyramid, why there will be twice the number of faces compared to that in a pyramid. All of these forms are named on the basis of the shape of the cross section, and a total of 21 different forms can be named from prism, pyramid and dipyramid. So, let us see these symbols here. Now, I am showing these crystal models in 3 rows here. This is the row where we show the prism. There are different types of prisms. This is an open form. This is the one for pyramid, and this is the one for dipyramid, and this is essentially the cross section of these faces in the horizontal plane here, and how they look like. On the basis of that, there are different classifications here. So, let us now first start with these different varieties of prism forms here. Now, this is a rhombic prism here. So, there are 4 faces here, and this is present in an orthorhombic crystal system with the point group of symmetry is 2, 2, 2. So, there are 4 faces, all 4 faces intersect along this line, and this is parallel to this vertical dyad here. Now, if you see here, in this case the vertical axis is a tetrad axis or 4-fold axisymmetry, and you have here 4 faces here 1, 2, 3, 4. Now, that is why we call it as tetragonal prism here. Now, if you see here that if there is a situation here that this face here that intersects the positive direction of A1 axis and positive direction of A2 axis, it is A2 axis. If it is subdivided into 2 additional faces here, and they will be one face here, another face here, and there are, instead of 4, there are 8 faces here, then we call it as, all they are parallel to each other and parallel to the vertical tetrad, we call it as ditetragonal prism here. And in this case, the 3 faces are present in the trigonal crystal system, and they are parallel to the vertical triad. And in this case, what happens? These 3 faces, each face now consists of 2 faces here. So, 3 and 2, there are 6 vertical faces here, all parallel to the triad. So, this we call it as ditrigonal prism here, and the one where we have only 3 prism faces here, we will simply call it as trigonal prism here. And what you have here is that in this case, you have here hexagonal prism here, there are 6 faces here, and if you have a multiple of 6 into 2, 12 faces here, then we call it as dihexagonal prism here. So, let us try to understand why in one case simple tetragonal and in another case ditetragonal prism is there. We see this in terms of this cross section of these faces here. So, this is here you have this 1, 2, 3, 4 edges here. In case of this one here, this edge now is subdivided into one edge here and another edge here. So, this particular one, for each of these face, this is now subdivided into 2 into 4, a total of 8 faces here in case of a tetragonal system here or ditetragonal system. So, that is why you call it as ditetragonal type here. In same way, when you have a simple triangle, this is trigonal prism, and when you have each triangle shaped face consists of 2 edges here, then we call it as ditrigonal prism here. Same thing applies for hexagonal prism here. So, here this is an hexagon, these are 6 edges here, but if you have one edge now consists of 2 edges here, and this one now consists of one edge here, another edge here, 6 into 2, then we call it as dihexagonal prism here. Now, let us come to the pyramid here. So, this is, you see that all the faces now intersect at a point here. So, you can have this one here. So, immediately you know that the form symbol will have to be 1, where it will be intersecting all the 3 crystallographic axes, or it may be parallel to one axis, but intersects at least the vertical crystallographic axis here. Now, what you have here is this is the tetragonal pyramid, but instead of 4 inclined faces, if there are 8 inclined faces, then I will call it as ditetragonal pyramid here. And this is a trigonal pyramid. Instead of 3, if there are 6 inclined faces here, then we call it as ditrigonal pyramid here. And this is an hexagonal pyramid, and this is dihexagonal pyramid here. Now, let us come here in this particular row here. You see a pyramid at the top and pyramid at the bottom. So, this set of faces, inclined face, intersect in the positive direction of this axis here at one point, and in the negative direction of this vertical axis here in this point here. So, when you have this, then we call it as tetragonal dipyramid, but when you have instead of 4 inclined faces at the top or 4 inclined faces at the bottom, there are 8 inclined faces at the top and there are 8 inclined faces at the bottom, then we will call this as ditetragonal dipyramid here. So, that is important here, the nomenclature is ditetragonal dipyramid here, and this is simple trigonal dipyramid, then this will be ditrigonal dipyramid here, and this is your hexagonal dipyramid, and this will be your dihexagonal dipyramid here. Now, one of the things that you need to know is that there must be some basic criteria that should be there, so that to make one pyramid to a dipyramid. One of the way you can do it is that if you have a horizontal mirror plane here. So, if you have a horizontal mirror plane perpendicular to the 4-fold axis, perpendicular to the 3-fold axis, or perpendicular to the hexad, then you can produce a dipyramid here. So, I give you some specific examples here for a tetragonal crystal form here. So, let us try to have a study with a very simple 4-fold axisymmetry here, or the point group of symmetry is 4, and let us have you have this is your vertical 4-fold axisymmetry, and your motif is 1 0 0. So, form symbol is 1 0 0. So, the vertical 4-fold axis will act upon this for 90-degree rotation. It will produce a face here, it will produce another face here, and it will produce another face here. So, you have here is that you have here that this is a 4 vertical face here. So, if you have another symbol here 1 1 0. So, if it is acted upon this 4-fold axisymmetry, you produce this 3 faces here, and this will all be prism faces, and it also start with HK0 here. So, this will produce 3 such faces here, and you have here these are all prism faces here. So, 1 2 3, this one, this one, this one, you have 4 vertical faces, these are tetragonal prism here. Now, if you have a situation that same HK0 here, if I put it H greater than K, so then with this you just change 4 to 4 mm, then we produce a 7 additional face here, and this is essentially will be 8 vertical faces. This will produce ditetragonal prism here. And if you have a simple 4-fold axisymmetry, and if you have an inclined face here H0L, so what will you produce here? You will produce simple pyramid here. But if you have a 1 which is a 4 over m, as I was telling you, this is a horizontal plane here, and that will produce a total of 8 faces here, then we have tetragonal dipyramid. So, this is essentially is what we call it here. Now, you have another set of isometric non-isometric forms, we call it as trapezohedron and scalenohedron. So, trapezohedron, this is a closed form, this is a collection of 6, 8, 12 faces. Each face is a trapezoid and is a plane shape with 4 unequal sides here, and the named according to the number of faces here. So, these are the essentially examples of trapezohedron here, And scalenohedron, this is a closed form here. So, it is a collection of 8 or 12 faces, each face is a scalene triangle, no two angles are equal. And the remaining two non-isometric crystal forms, one is called rhombohedron, is a closed form here. This consists of 6 faces, each face is rhomb shaped here. This is the example of rhombohedron here. And you also have a tetrahedron, this is a closed form here, there is a triangular shaped, 4 triangular shaped faces here. With this, I come to an end to this course on crystallography here. From next class, we will start a new topic here, that will be on optical mineralogy here. So, I request all of you to attend the course on optical mineralogy. Thank you.